Hey folks, welcome back to another video. In today's session, we're going to be talking about photogrammetry. This is a skill set that I think more 3D artists should have because it is so easy these days to get it right. So in this video, we're going to be doing a little bit of talking about photogrammetry, talking about the app that I like to use, and then we will be talking about how to process scans. These things come through heavy, super high detail. They need some processing. You need to understand how to actually put them together, multiple scans merging, and then baking down to low resolution. So there's a few steps that I want to go through here. It's really just to help you guys upskill and get in on some of the benefits of photoscanning because it's such a powerful skill set. Once you can take anything from reality and put it into a 3D scene like I have here, and you can see that we're getting a huge amount of detail on here. We've got all of the graffiti. Like definitely there's a little bit of texture stretching. This is also probably because I baked it down to lower resolution textures just to make it a little bit more manageable. But all of the mesh details, all of the structure of this is basically free. You get it all nice and easy. So a few considerations when doing photoscanning. First of all, we need to understand what photoscanning is, how it is going to be thinking about making 3D meshes. And then we also want to know what software to use for it and how to deal with the output of that software. So the general idea of photoscanning is that you take a lot of pictures of an object, for example our Suzanne here, and by comparing the differences in specific features between two photos, we can identify, in theory, the three-dimensionality of it. So if you have 3 points and you have this sort of affine perspective change, then you can understand something about the surface and reconstruct the three-dimensionality. To make this a little bit clearer, I've just put together a quick little geometry nodes thing. Feel free to download this if you want to have a look at how I've made it. You can see that if you take a lot of pictures of this from all different sides, and then if we lay them out on a grid, and let's just isolate that, then you can see that if we have a position which is here, next to the ear, and then on this one, those 2 points are closer together, then we know that there's been a rotational change to our object. And with enough of these images from enough angles, you can actually get a very accurate, very detailed version of the surface. So rather than just taking a few photographs as we have here, this is what, 80 photos, maybe you would also try and get some from underneath to give yourself more coverage, because you never want there to be any part of the surface that you want detail on that you've not looked at. And then you'd obviously infill a little bit more with more photos in other places. To get a really quick coverage, what I would recommend you do is, first of all, just go on a little walk around your object, just at a neutral level. Try and get a good coverage of images. Now, if you're using the free version of Kiri, you only have 70 images. So I'd say try and get around 20 images going around in a circle. Next up, you want to get a nice little arc over the top. So we're just going to do a pass over your object just to get a nice little pass around the surface. You can obviously come down below as well if you're able to mount it on a stick or put it on some kind of plinth. Or if it's, as mine was, a large statue outside, it will have a natural termination with the ground, and you just want to make sure that that is included. You're then just going to do another one in the next direction. So at this point you have your 3 axes kind of covered, and then what I would recommend is you do another loop around from a little bit higher up. Just make sure that you've got the top details, and if you can, get the bottom ones as well similarly, and then do little rotations around any detail areas that you're specifically interested in, making sure that you haven't missed anything. So for example, the ears of Suzanne here, we might do a little near path just to make sure that we have a real clear understanding of what the geometry is doing in that space. Something to talk about as well is going to be lighting. So you definitely want as even lighting as possible. If you're going for an outdoor kind of shoot, you do not want to do this on a sunny day. The problem with doing it on a sunny day is kind of twofold. One, it means you're going to be baking shadow data, light data, into your textures. So you're going to permanently have shadows. It makes it very difficult for you to relight things, and trying to modify your textures to get rid of those shadows, you can do it. It's just a little bit difficult. The other problem with this is if you're using your phone for doing the scanning, then you are more likely to have issues. And I suppose if you're using a camera as well, you're going to be having issues with auto exposure changing the exposure between shots. When you're doing a highly sunny side, if you're getting very bright surfaces, then you come around to the back and you've got shadow, your camera is going to boost that and it's going to change the lighting information, and you can lose your tracking, or you can get strange undulations in the surface around the edges of shadows. So if you can do it outside in full overcast when it's dry, then that will give you much better results and you can relight your model much easier. If you're doing it indoors, then you can do a huge amount with portable lighting. If you have torches and things like this, I wouldn't recommend using a torch directly on the surface, but if you can get a white sheet of cardboard or a white wall, shine the torch at that surface so that you get a lot of reflected bounce lighting, and then you can get a nice sort of diffuse glow around everything. It just makes it a little bit easier to get a good scan. When it comes to actually doing your scanning, you have a few options. I'm going to recommend that you use Kiri Engine for a few reasons. First of all, I really like the developers. I think they're really cool people. You can follow them on YouTube and Discord. And also the pricing is much less than something like Polycam or some of these other premium services. Kiri Engine is exceptionally good as well. The quality is very high and it's multi-platform. So it's on Android and iOS as well as in the web. So if you just want to take photos and then upload them to a website and have it processed there, you can do that with Kiri Engine. Free version, perfectly usable. You can do 70 photos, or if you pay, you can do 200 photos in a scan. And if you are not paying, then you get 3 exports per week. So you can scan a bunch of things and pick the 3 you want to download and download those ones. While I do recommend Kiri Engine because it's multi-platform and it's relatively inexpensive, I would just want to say that I'm not being sponsored for this video. It is just something that I genuinely like using. When you open Kiri Engine, you're going to get your library with your recent scans, and these are not local. It's just something to be aware of. This is like your online library. Scans and models are not stored locally on your phone. You will need to essentially download them. It can take a little bit of time. It's not instant. When you say, oh, I want this file, they will basically email it to you, but it will go through processing on their servers first. So when we come to doing a scan, we're making a new scan, you can go ahead and click the plus icon at the bottom. I'm on an iPhone here, but you can absolutely do this with just a regular Android phone. I've tested it on these and it's perfect. And even with this low-end Xiaomi device, you can get really excellent results as well. Photogrammetry is fantastic for this because it's doing feature tracking in image. Even a low resolution photo has a huge amount of points of information in it. So in Kiri, you can do scan with LiDAR, you can do featureless objects. This is something like a smooth surface, like a drinks bottle, for example, where you only have one color across the surface, and it's going to try and understand the 3-dimensionality using AI. You can also upload local photos if you've taken a bunch of photos, but you've not done it in the app, or the option that we're interested in, the bottom one here, take photos. And I apologize for the mess in the background. This is not normally an angle that I film. But for example, if I was wanting to scan this little pot here, I have a few options. I can take the photos manually, that is the default, and you just press the shutter, you can see the count on the bottom left. Or you can use the record function, and this is actually probably what I'd recommend most of the time. If you're trying to be really low on your images, then take them manually, but the recording version will not take a picture until the image is sufficiently different. So let me show you this. If I hit record, it's not going to start taking more photos until I start to move. And you can see that we're getting a bit of a blink on that screen as we come around here. So what I would generally do, I would do a little wander around it, get all of the angles on a neutral height like this. I would do once over the top in this direction. I would do once over the top in this direction. And then I would do some specific detail shots, trying to make sure that I'm getting all of the different nooks and crannies, as well as getting really low on it as well here. For something like this, you might want to put it on top of a narrow pot, just so that you can get something underneath. And another thing you can do, if you do pay for the pro version of Kiri Engine, you can set manual exposure ISO and shutter speed, which means you're going to get much more consistent photos. So that's going to be a little bit better quality. But you can also set a specific time for each photo, which means you can use something like this. This is a little USB turntable, and it just turns around very slowly, which means when you're using photogrammetry apps with a timer, you can just simply point and shoot, and it will just do all of the work for you, basically. Very consistent photos. And yes, you can get very high quality scans that way. Back in Kiri Engine, you can see in my library here, I have two statues. I have the Priory statue and I have the Precinct statue base. It's totally fine as long as you plan it to take multiple scans of the same thing to get high detail on different parts and then join those things. So as I move around this 3D model that came back from my scan, you can see I focused heavily on the lower section, on this plinth section, and I made sure to get all of the connection to the ground as I went around here. So that was my focus. I didn't think about the top section here. In fact, I didn't even bother scanning it. You can see some of the details here, but that's just from sort of overdraw from the lower section. Doing it this way with an object like this means that I can splice these together, and these have a really nice connection line just on this upper plinth section. So we can see we have this raised section above. I can simply cut this out in Blender and replace it with the high quality one from my second scan. But the important thing is just make sure that you have a lot of different angles on a lot of different parts, because when you're scanning, it's really easy to just do it from where you're looking at. You've got to remember these are 3D objects and they also have an underneath. Then I've got my Priory statue, which is the top part. You can see there's a little bit of overdraw for the bottom, but otherwise I really just focused on this top section here, just to make sure that I had all of these details in how I wanted. And then once again, I can just cut along this sharp edge and splice it onto the one below. If I expand this section at the bottom where it says low poly model, we can see that the low poly face count's 15,000. So that's what we're looking at on the device. But the high poly face count, the full resolution scan, is 6.7 million faces. Scans are dense topology. That is something I want you to understand. So when I download this, I'm going to get two versions. I'm going to get a low poly version and I'm going to get the high poly version. And it's the high poly one we're going to be working with now in Blender. When you get your scans into Blender, they can look a little bit rough like this, and we're just going to do a little bit of processing here. So first things first, we need to make them the correct size and orientation. We have two scans here, so we want to make sure they're also sitting in the same place. With Kiri Engine, you'll notice that you have an empty with the mesh below it. In this case, I don't really need the empties, so I can just remove those and be left with the meshes. And then what I'm going to do is just one at a time, I'm going to rotate these into being sort of orthogonal. I want to make sure that I'm pretty much aligned to my world axes. It just makes it a lot easier to work with them. And I'm just using this has really clear lines on it, so I'm just going to try and use these as much as possible here. Just to get things more or less in position here. You can see in wireframe just how dense this mesh is. And yeah, something like this is pretty good. And we can see with the texture, you get it just looks like a lot of detail with all of that color information on there as well. So just the mesh itself, you can see there's a lot of kind of uncertain geometry happening. We have a few ways to deal with this, so let's jump to it. Our actual object in real life was approximately 2.1 meters long, I want to say. So I'm going to add a cube. And we know that our cube starts at 2 by 2 by 2. Let's start this at around about 2.1 just to make it a bit longer. And we're going to scale towards our 3D cursor and just scale down here. Okay, somewhere like this, and I'll also just center it. Just for good riddance as well. There we go, and then now I've got the right size and rotation. Let's apply rotation and scale. Let's jump back to our main section for the top. And we're just going to do the exact same thing here. So rotate it to meet your orthogonal axes. Somewhere like this. something like this, and then we also want to rotate in the other axis, and then we're just going to scale it down. This time I'm going to be scaling it to match the first one. So rotate 180 degrees to get them to match up. And they should be pretty close to each other here. Let's just get them lined up as best we can. Nice little trick as well, if you're trying to line up a face like this and you're not quite getting it right, then find where that corner is. So it's somewhere about there. I'm going to go shift right click on that corner to get a 3D cursor. I'm going to go into 3D cursor as my rotation center. And now if I rotate, I'm rotating around a known good. So I can just swing it in towards that side. You can have a look at our scale. It seems pretty good actually there. Might be just a little bit bigger. Move it very slightly. There we go, nice. That's looking good. That's a good match that we have. Again, apply rotation and scale, and then we're good to move on to the next step. Let's grab our ground here. I want to remove everything that is outside the base of this plinth. You have, again, a few options. One would just be going to edit mode. And then in vertex selection mode, you can do a control right click and drag to get a lasso selection, and then simply delete as you go. Would I recommend this? Probably not. We have a simpler method that we can use here, and that is going to be booleans. Add yourself a cube. We're going to be making a very simple boolean. We want to go back to our median point transforms. Transform center there. And we're just going to be putting this on very, very close to the edge of our plinth. Now, right now, this would be causing problems because we would be trimming off parts that we don't want. But it's important just to make sure that we are very close to begin with. This is actually a pretty good approximation. Pretty good here, pretty good here. And then what I'm going to do, everyone has a different process for this, but I like to move it down very slightly. I'm going to add with Control R a loop cut, which I'll bring down just above ground level, very slightly, like this. And I'm just going to bring these out now at quite a sheer angle. So we reach ground level, and then we're going to have a little bit of a shadow gap just underneath the bottom of the plinth here. It makes sense for an object like this, where we have a very, basically when it's stone on top of stone, it's not a continuous surface. I'm going to take the other axis as well, just to make sure that we've got that here. And we'll go for around about 45-degree kilter there. And there we go. So we have a nice little dip underneath, and just a very clear differentiation of what we want to keep. We can take our main object here, we're going to add a new modifier. We're going to generate and then boolean. And I will say, just before you set your boolean object, save the file, because booleans are heavy, they can crash, and we're dealing with a very high resolution mesh here. We have currently 9.3 million polygons. We're interested in an intersection, so we're interested in when these two are both contained within the same space. And our object is going to be this cube that we just made. Now, one trick that you can do that I'll show you on the next one is going to speed this up so you can actually do it twice as fast. Now we finished that Boolean operation. I haven't applied it. I just want to make sure that we actually have faces underneath. So I'm selecting my cube. I'm going down to viewport display in our object properties and display as wire. It's important to make sure that you have actually created that bottom section, because we do want manifold geometry here. So we can see in this case we have not been able to create manifold geometry. We have a lot of openings around the edge. So what I think I need to do is probably just bring it in and down slightly. Because we have a Boolean active, this is going to take a little bit of time. So what I'll do first is I will disable the Boolean. And then I can go into my object here, go into wireframe. And make a few corrections. All right, so this time I raised this very slightly up and I just made sure that I brought it in a little bit closer. You can see that we're getting some artifacts around here where we've basically cut through plants and things like that. You can tweak this as long as you want to, really. And obviously your scanning is going to be different. So the important thing really is just to create manifold geometry. So I want this to be solid underneath, just so that when we do later Booleans, they are more likely to succeed. Also means that you have more freedom with moving things, hovering over edges and things like that. Let's go ahead and apply this Boolean modifier. I don't want to have that kind of proceduralism active on a mesh that is this complicated. Let's apply this. And this is where we can make an optimization if you're confident about your Booleans. A modifier will be computed when you first create it, make it visible, and also when it is applied. Rather than doing all of your Boolean computation, both when you actually set your cutter and then when you apply it, if you have a cutter which you're confident about, you can simply disable your modifier, set the cutter object, and then go straight to applying it. And that's what we're going to do for this top section. So let's add a new Boolean. So this is generate Boolean in Blender 4.0. And straight away, let's just disable this modifier. And I'm going to take my cutter object here. I'm just going to use the same one. This time, I will actually dissolve the bottom section. And let's work out where we want this. So this time it's a little bit different. It's a little bit narrower. And these edges are a little bit less uniform, actually. So we do just want to try and keep as much as we can to the surface. And just get them just on the outside of these corners, even where you have undercuts like this. Something like that should be fine. Now you can always sculpt in on these meshes as well once you process them, just to smooth bits out. But it's good to get as far as you can with these simple automated operations, just to simplify the mesh down. And then maybe do some of your cleanup later once you've also decimated and you have a bit less to work with. So there we go, that should be pretty much on those edges. Maybe a little bit tight on this top edge. I think that's probably okay. And now we can go back to our object. We're going to be this time using a difference operation because we're trying to just remove this top section. So while our Boolean modifier is disabled in the viewport, we're going to select our cube. This should be faster than trying to do it while it's all enabled. There we go. And then we can just immediately go straight to apply. Obviously, if you're checking things and you're not quite sure about whether something's going to have worked, it is faster to not do this because you're going to need that feedback. But in a case like this, where I think it's fairly straightforward, we have a top section which is very clearly manifold, then you're more likely to get a good result. The bottom one is more likely to fail because you just go to like an open void, which mesh Booleans and trying to calculate the inside of a mesh isn't so good at. So there we go. I'm going to delete that now. We can see that we have a little bit of kind of an edge around here, but for now I'm just going to leave it as is. I can come back in with a sculpt brush in a minute. So I'm going to select my object. I'm going to go into edit mode. I'm going to click off, make sure I've not got anything selected, and then I'm going to select a single vertex and I'm going to press Ctrl L to select the island attached to that vertex. We can see from the black spots on here that we have a lot of mesh which is completely disconnected. I'm going to press Ctrl I and I'm simply going to delete all of it. So I'm only interested in mesh which is completely connected to our main surface here. Now if we have a look in our material preview mode, you can see that our top and bottom Booleans are quite ugly. They're not going to give us nice rock surfaces. So let's go ahead, just while we're still in this headspace, we'll go into our UV editor and we will select the image for this section. Let's get back into edit mode. I'm going to select my top face and I'm going to press U, unwrap. And I'm just going to scale it down, a bit choppy, but we're going to just stick it on one of these sections of stone. Now in theory, it's all going to be underneath the other part of our object, but it is good just to make sure that we have a color match to the adjacent topology. So let's just come in and I'm going to put it on one of these edges here. You can do exactly the same thing on the bottom. So select your bottom face. This one is even less visible, so I'm just going to select it, make sure it is disconnected. I'm just going to unwrap here and I'm going to position it down onto one of these gravestones, which is more the color of the ground. There we go. So now I have something which is a little bit better for our surfaces, for our color matching here. Obviously you don't want to look at these faces, but we're going to be covering them up anyway in just a moment. So same process for this one. We're just going to go through here, create our Boolean cutter, isolate this top section, and then remove any mesh islands. Like I can see one here that we want to get rid of. So let's go ahead, add our mesh, and we'll get to it. And there we go, we're back. So now we have a top section which is sort of cleaned up, although not processed yet, and a bottom section which is much the same way. And what we might want to do is just get these to sort of sit through each other a little bit, making sure that one Boolean face is covering the other. Now this does become a little bit more challenging if you're dealing with geometry that is very much continuous. It's going to be important for you to try and find ways to break it up in a way which makes sense. I'm just doing some minor scaling rotations just to make sure that I'm covering up as much of that section as possible here. There we go, that looks like it's covered it now. Excellent. All right, now I don't really mind these being separate, but when we come to do our bake, we're going to want to make a joined version, and we're going to want it to have good topology, and we're going to want it to be just a little bit more workable. Something to be aware of as well, if doing the booleans on such high resolution meshes is not possible for you on your hardware, you can always start off by decimating. Because of the state of the mesh, you see some of these little pinches and things, you can actually get a lot of cleanup to be done by collapsing in your decimate. So right now we have just over 6 million. If I was to set my ratio down to 0.1, I would expect to have around about 600,000 faces, which is still high resolution. It's going to take me, a minute or two for this to actually process, but once it's done, there's going to be a lot more headroom in Blender for it to do things like mesh booleans. So you can see now the mesh looks much how it did. Not really losing much, but I'm 1/10 the density. If I turn on my wireframe drawing here, you can See, it's still super dense, but much, much more workable. So you might want to just start off by doing that to make a mesh which is a bit more usable for you. So I'm going to do that to both my top and my bottom here, just before I continue, just because we've got a few more steps to do here to make sure that we're smoothing out this mesh nicely. All right, this is all looking a lot cleaner. We also have a lot less topology to be working with, but we're still not done. For example, you can see that where I was very close in my photos, we have a lot more detail, a lot more data points. And obviously this is post decimation, but that change of density is still going to be present all over the place. You can see these areas are much denser. As a result, we're going to want to do a few steps just to join everything together into one asset and then smooth out, make the mesh just a lot better, basically retopologize it. But we want to do it automatically. Now, with an asset like this, you do have a few options. If you're doing a very low resolution game asset, I would recommend that you literally come in here and box model over the surface, maybe snapping to the surface. It's all quite repeated, and then you can bake your normals onto your low poly version. In our case, we're going to be making a still quite a high resolution mesh, but one that you can then decimate down from a little bit more consistently. I'm going to actually duplicate my current collection. I'm going to hide my original one because I'm going to be using that in the next step to bake from, because I want to bake normals. And in this case, what I'm going to do is I'm going to take my base, I'm going to grab another Boolean modifier, and I'm going to do a union with the top. Now, don't forget, I've also pre-decimated these, so these are 1/10 of the resolution. So it just makes it a little bit quicker. Let's apply this Boolean, and I can now delete my top piece. And you can see that we now have just a single mesh in here. If I fly into the mesh, then we don't have this internal face. If you do, then it's worth just trying to move it a few different places until you no longer get that glitch happening. So we have this nice singular manifold mesh. That makes it easier now for us to process this a little bit. I'm also going to just put this into material mode so that you can see a few things. So as soon as we join this together, we messed up all of our UVs on the top because it all got the same material, the same single material. The next thing that we're going to want to do here is actually just remesh it. And as soon as you remesh, you lose all of the rest of it. So it's still being assigned a material, but the UVs have been set to 0, 0, 0 for everything. This means that we are no longer able to sample a UV map correctly. Set our voxel size down to something like 1 centimeter. It's going to be quite high density, but that should be fine. And then we can also do a shrink wrap in here, which is under deform. And I want to be shrink wrapping to the nearest surface of, if I just duplicate this object again. And on this duplicate version, I'm going to just remove the modifiers just so that we go back to that original mesh. If I put this into my target, then you can see that we are now sticking nicely to the surface. So we've got a little bit of that detail back. If I turn on smooth shading, what are we getting? Oh, we're getting still some crinks in here. If we go fully smooth, so not auto smooth, we want it fully smoothed. I think it's probably still okay. How many faces do we have? We're looking at 300,000 triangles. That's pretty good. So I've done my remesh, I've done my shrink wrap. I'm just going to apply both of these in order from the top to the bottom. And then we want to bring up a UV editor and a shader graph. So first things first, let's create a new material on this object. So it's going to be our tomb material, just tomb. And in here, you can see that we have our new principled BSDF. Coming off our base color, let's just use an image texture node, again from the color, and it will default to the UV map, but let's just be explicit. Let's grab a UV map node. And we want to make sure we currently don't have any UV maps. Let's create one, and we will use this. We're going to be creating a new image on here. This one is going to be our tomb diffuse, so for our color, and our width and height is going to be 4096, so 4K texture. I'm not going to be storing any data in the alpha channel, so I don't need that. And I'm going to click OK. Let's open up our tomb diffuse, and you'll see it's just black on here. If we go into edit mode, you can see that our mesh is now nicely quad topology. Obviously it's still very dense and you get some strangeness going on, but it's totally fine for what we want, and it just makes decimating a little bit more predictable. And you can also subdivide it and whatever else you want. So we're going to be doing an automatic smart UV project. No need for us to do anything more complicated. Let's have a look at what this is going to come back with. So quite a lot of openness in here. Let's try with a lower angle limit. That's giving us a little bit more tightness into that space. I think that's probably fine. And I will set just the tiniest bit of boundary margin. Probably doesn't need it, but we have a lot of these little faces, individual faces. That might be raising alarm bells, but in this case our bake's actually going to work out fine, so I wouldn't worry too much about it in this case. Alright, quick bit of baking here. Baking is super easy, honestly, when you have something like this, but there's something to be aware of. Temptation here, we need to be in cycles. We're going to bake. I'm going to be baking the diffuse, and I'm only going to be baking the color. We're going to be doing selected to active, and our output is going to be an image texture. So we need to make sure that our image texture is selected and active in our target. I'm actually going to reduce my margin here to around about 5 pixels, and then I would just say bake, but we need to do selected to active, so let's select our original meshes up at the top here. Then we're going to control click in the outliner onto our decimated version, sorry, our remeshed version, and we're going to just hit bake. This is going to just take a second, and I'm hoping it's going to break for you, because there's something to be aware of here. All right, that is now baked. And perfect, yes, it's done exactly what I wanted to show you. So you can see that this looks terrible, just awful. And the reason for that is because we tried to bake from 2 separate objects at the same time, sort of in the same space. And what this means is it's not baking from them at the same time. If you watch the progress bar at the bottom while yours is doing it, it will bake one, and then it will bake the next. And technically also what it's doing is it's baking individual mesh islands, one by one by one, and then it will go on to the next one. What this results in is a garbled mess of surface detail. So rather than doing that, what I want to do, I'm going to select my new remeshed version, and I'm just going to walk around this top and control click into each corner. Like this, and then back to that last one. And what we can do is we can go up to our select menu, select loops, and select loop inner region. You can now see that we've selected that top section. Press P and then separate by selection. Now what we have is 2 separate meshes that have vertices in exactly the same positions, which means that we can rejoin and merge to fix them back together. I can delete that other object. We just had that for shrink wrapping. We're going to go back to our collection. I'm going to bake from the top onto the top this time. So nice and easy. We're going to not clear the image. We're just going to hit bake, and we're going to let this run through. And then the next one, we're going to bake from the original bottom onto our new remeshed bottom. Select one, select the other, and then hit bake. This whole time, we've had our tomb diffuse texture as our main selection. And this just means it's always knowing to bake onto this one. Once you're baked and you're happy with your results, make sure you go up to your image editor here, click image, and then save as. You definitely want to be saving your images, because otherwise they will not be saved, and then you will have to rebake later. Once you're all set with this, you might find you've got a few bits which you're not super happy with, but best thing to do here is just select your top and bottom, Control J to join them together. Select all, go into edit mode. Select all your vertices. Click M, merge by distance. Now you're going to get all of these as a singular mesh again. And then what we can do is we can press Control Tab, or you can go up here into our menu, go down to Texture Paint, press N, Tool, and we can see what we're working with here. So I want to make sure that I'm in the Tomb Diffuse image. We're going to bring up our clone stamp brush, and then let's place our 3D cursor, and then we can just brush along this edge here, just like this. Nice and simple, just to smooth this out. Your other alternative is to use the soften or smear options, just to give you a little bit of softness on that edge, just to make sure it doesn't look like it was a hard break on there. Now when you do it with the smear or the soften, it can look distinctly softer, so you might also just want to mix in a little bit of the definition of that actual image using your clone stamp. Now it's also a good opportunity just to run around, have a look at some of your bottom edges, just to make sure that you've got rid of some of these artifacts that you will likely have if you've got this boolean. We just want to take some of this texture around the edge, just to make sure that we have nicely merged it in here. Don't worry too much about this, because people using this in scenes will be using some like little skirts and things to break up the texture and make sure that it is properly integrated with the ground. You know, you'll have little bits of plant assets or actual objects that obscure the edges. So you don't need to be too fastidious about it, but it is just useful to make sure that you don't actually see any flashes of white or anything just around the edge. Once you're happy with all of the different bits of texturing that you've just done, you can always check if there's any parts of the actual mesh you want to modify still. For example, I've got this little hook coming out here that I might want to just come into sculpt mode, press shift and just smooth it down a little bit here. Equally, if you have anywhere that photogrammetry can't really pick up well, for example, there was a puddle on these feet, that really ought to be flat. So you might want to just come into sculpting here as well and just smooth it out a little bit, just to make it make sense on here. There we go. Final stop for us to do is going to be normal maps, and this is a nice easy one. We already know how we're going to do our baking, and we just want to take a new image texture in our shader. Let's remove this image. We're going to create a new one. This one's going to be called Tomb Normal. Again, 4096 for our 4K. We want this to just be as it is. Set our color space to non-color. I'm going to plug this into a normal map node as the color, and then this will come back into our principled normal. Now, by default, this looks terrible because we've just put in a normal map as a value of black rather than neutral, because they're neutral around 0.5, 0.51. That is their kind of central position. So in our case, what we want to do, I might just hide that for a moment. Once again, we're going to take our seam line and just sort of split off this top section. You could have done this before we did our rejoin, but I do like to do that texture fix before I do. So I'm going to grab that loop, select loops in a region, P, separate by selection, and now I can bake my top, and then I can bake the bottom. So I'm just going to grab my original higher poly versions and then control click onto my low poly remeshed versions. This time we're going to be baking a normal map. This is all fine. I've got a cage extrusion of 2 centimeters on here, and I've reduced my margin size to 1 pixel just because I didn't have very much space around those small islands. Let's just go ahead and click bake with our tomb normal being the one that is selected. And then we will just do the flip side. So let's grab our base and our new base, and again, Make sure you do not have clear image turned on because we're doing a separate one on the same image. And let's hit bake again and just let this run through. It's always good when you're doing a normal map just to do a little bit of a sense check. So this is the approximate color that you want. If you see anything which is bright yellow or bright red, it's quite likely that you have some failure points on there. So this is going to be an artifact. This is going to be an artifact. I would expect anyway. In general, looks like we don't have any large issues. So let's go ahead, hide our original base here, grab our normal map, plug it in, and if we just mute our base color, let's have a look at this on the object. If we want to have a proper look at this, let's go into cycles. And I'll just turn off the scene world and I'll go with something that's got a little bit stronger directional light. So I can cast a shadow over here. So you can see we have all of the information about this stonework here. But if I mute that noodle from my normal map, that was Shift Alt, right click and drag to get my mute. And you can see that none of our retopologized mesh, our quad mesh, has any of that information. So that is all in the normal map. Once again, make sure that you have saved your normal map. And any changes that you made to your diffuse as well, make sure that you've saved that. And now, just join these back together, Control J, tab into edit mode, select all, M, merge by distance, and there you go. So that is basically how you can go and steal 3D models from the real world. It's a fantastic skill to have because it means that you can get really high quality props very easily, and you can start creating stories and telling stories using elements that you know and see and can interact with. And also it sets a bit of a baseline for things. You can have this in your scene and it means that everything else needs to be up to that standard, so it can be a little bit of criteria to help you work. Or you can find a little bit of a workflow for stylizing these. Do a little bit of retopology, do a little bit of procedural work on top of it. You can get some really compelling results. One thing to consider if you're doing this kind of cultural heritage scanning, I would recommend or suggest that you put it on somewhere like Sketchfab or BlendSwap for free, just to make sure that people can get the most out of the world that they live in. And this process can be largely automated as well with some scripts, so you can do a lot of it very quickly. I know this one was a little bit different. We didn't really touch on geometry nodes, but photogrammetry, photoscanning, it's so easy now with supercomputers in all of our pockets. There's very little that holds you back from just being able to go out and get these things. So I want to make sure that you are even just aware that it's an option. You can always grab Kiri Engine for free on Android and iOS, and it does a fantastic job. And actually, one thing that I should just mention, so when you're going to download your actual scans at the end of it, if you are paying, then you can do a little bit more processing on the app. So you can go to the advanced export section and you can actually get them to generate the quad mesh for you. And if they do that, you will get both a quad mesh and the original scan and the low poly version. So in that case, you can do all of that retopology work that I did manually inside Kiri Engine directly. And they will just send you essentially a finished mesh. They won't have the same control over like how you want to boolean things together and do the cleanup. It will just be a processed version of the scan. But if it gets you ahead, then that is perhaps something worth doing. Hope you enjoyed the video, hope it was interesting and you learned something. Now I'll catch you in the next one for a more regular geometry nodes adventure. I'll see you there.